Okay, what we're going to do is we are going to compare figure 1, which is going to be our baseline figure. We're going to compare him to all of the other 6 figures. And our whole purpose today is so that we can see how to do transformations without any words. It's going to be cool. You see those 2 transformations on the board there? Any idea what those mean? Can you tell me if they're a reflection or a rotation or a dilation or a translation?
It's a reflection. The first one looks like a reflection.
What we're going to do is by the end of the hour, you are going to be able to read and understand what those 2 directions mean. Isn't that cool? You're already going to have 2 of them under your belt. They're the 2 easiest. You're going to find them based on these little smiley face figures. Okay, take out figure 1 and figure 2. Okay, if you have the others, you can just put them off to the side. Now, based on just figure 1 to figure 2, if we're just looking at size, how would you say figure 2 compares to figure 1?
I'm bigger.
It's bigger. Okay? So this top hat organizer, I know we've used them before, but it's a great way to show the differences between things. And it's also a way to help us analyze and to keep all of our notes down as we go. Now, it is bigger. Would anyone like to take a guess as to how many times bigger it is?
3.
3?
2.
2? 3?
Just a second.
Okay. Oh, we got some people that are looking a little bit closer. Oh, we have some people that are putting it on top of another paper to kind of look. Let me show you a very simple way that we can compare this. On your points page, can someone give me the first point for figure 1?
6, 4.
Okay, I'm going to just record that over here in the first column because we're going to always compare the first point of figure 1 to the other first points of the others. Now, you said it was bigger. What is the first point of figure 2? Let's actually look at this.
12, 8.
12,
Oh, it's
8. Ah. Now, I loved what you guys were doing. Some of you were counting side lengths. Some of you were trying to see how much bigger they were by looking through the 2 papers into the light. Some of you were, I don't know, you were looking at something. You were busy analyzing something. What we can do is we can analyze these points, but let's make it simple. Let's just look at one point. And your brain is now wired because you're now like, wait a minute, she's asked how many times bigger. Your brain is already going, how many times bigger? And what are you saying now? 2. Why are you saying it's 2 times bigger?
6 times 2 is 12. 4 times 2 is equal 8.
6 times 2 is 12. Yeah, that held true. 4 times 2 is 8. That is exactly what they wanted you to find. It is 2 times bigger. Now, when we talk about this, and you may want to look at your examples at your desk, it's the side lengths that are 2 times bigger. If you look at the height, could I get 2 of the little guys?
No.
No. Oh, really? Did you graph them right? If you look at just the height, here is figure 2. Can I kind of just do a little folding on yours?
If you have one more box there.
If I look at just the height, is it 2 times bigger?
Yes, it is.
Yes, it is. Okay. If I look at the width of my little guy, let's line him up. Oh, this one, hang on here. Let's double check. I need another figure 1 and figure 2. This is a quick way to go ahead and check.
It could be drawn on there.
It could be drawn that they accidentally drew the wrong, plotted the wrong point.
Or like when they're making their
Okay, is it
little
2
line.
times bigger?
Yes.
Okay, and let's double check their height. 2 times bigger?
Yeah.
Okay. When we're looking at these points, we're actually looking at that the length and the height are 2 times bigger. Okay? If you look at the area, how many of these little guys would actually fit inside the big guy?
4.
4. So the area, I'm just going to record that since we found that. The area is actually 4 times bigger, but the side lengths are 2 times bigger. This is how you're going to record it. Jump down to where it says rewrite the coordinates. The x value was twice as big, 2 times x. The y value was twice as big. Now, if something gets bigger, what kind of transformation is that?
Dilation.
It's a dilation. You just found how to communicate a dilation by just using the coordinate points. This right here says, hey, this is a dilation. If I perform this transformation to my points, it's going to get 2 times bigger. Let's look at the points here. Let's just check this out. I'm going to pick another point. 1 and 1, 2 and 2. Did it get 2 times bigger? Let's go -1 and 1 and -2 and 2. 2 times bigger? Let's pick something that we haven't seen here. 3, -3 and 6, -6. Twice as big? Okay. I don't need to go through each and every one of them. They're always going to be 2 times as big. Are the figures similar then, if you look at the 2 shapes? Would you say they're proportional?
Yeah.
Okay, so let's just go ahead and write down, yep, they are similar, or they are proportional. And that's one thing we already learned with dilations. They are equivalent ratios. They are proportional. Just like the recipe you did yesterday for your ice cream, you were dilating it, making it bigger. Okay, it was proportional because you want your ice cream to taste the same, or you made it smaller and it would still taste the same. Okay, let's put figure 2 away, take out figure 3. And if I remember right, figure 3, something weird happened to figure 3. Yeah, what happened to figure 3?
Really long.
It's like,
He got ran over.
yeah, we stretched him out. He is definitely wider. What about the height? What happened to his height?
It stayed the same.
Oh, it stayed the same? Oh, okay. So I'm just going to put same height. So the only thing that we did is we stretched him out, but we kept him the exact same height. If you have to just double check, you can figure that out there with the pictures in front of you. What is the first point for figure 3 based on your...
18.4.
Oh, well, that's interesting. You guys just told me that he was wider, but he had the same height. Look at this point. Compare it to the first point. Does that say the same thing that you just told me based on the pictures?
Yeah.
How can you tell that it's the same height?
The board didn't change.
Students and teachers, this is the last call for retakes. Please report to the cafeteria. Thank you.
You're right. You guys just told me that on your picture it's the same height. When I look at the points, yeah, it stayed the same. Now tell me, how many times wider is this guy?
3.
3. If you look at your picture, does that hold true? Is it really 3 times wider?
Yeah.
Are we still going?
Yeah, figure 1 will always stay as our baseline. Is it really 3 times wider? Can I get 3 of them across there? Yes!
Figure 1.
Crazy! You looked at the pictures and you said he's wider, but he has the same height. We look at one coordinate point and it says the same thing. It's 3 times wider, but it has the same height. Yes?
When we write that, like how you did the 2x and the 2y, would we put a 0 for it?
Oh, okay. She's starting. Okay, Alyssa's jumping down here now.
It'd be 1 because you don't want times it. Yeah.
She's like, okay, how do we write down what happened here? How would I tell what happened with the x?
It'd be 3x
It would be 3x,
and then 1y.
1y, to be honest, mathematicians, algebrainians, they don't want to take the time to put 1y. So you know what they're going to put?
Y.
They're just going to put y. They're going to say, hey, I know when I take something times 1, it stays the same. So I'm just going to put that there. Plus, it does just stay the same. There you go. Now, here's the thing. Is this a transformation?
No.
Did it translate?
No.
Did it rotate?
No.
Did it reflect?
No.
So it's
Did it dilate?
No.
Yes.
yes.
No, it doesn't
Only
say
one
proportions.
piece, but it didn't stay proportional. It is not similar anymore. It got flattened out. Well, it didn't really get flattened out because he's still the same height. He just literally got stretched wider. And it is not proportional, so that means it is not a dilation. But the cool thing is you've already moved your thinking. You already know how to say, this is what happened to it, though. I can tell you exactly what happened. Look at this. If I look at my points, let me just pick a point here. Let's just pick this one, 4-2 and 12-2. Did the height stay the same?
No.
And did it get 3 times wider? 4 to 12?
Yeah.
Perfect. We got the rule. Yes. Tanner.
Did you mean to put not? Or-
I did. It is not similar and it is not proportional.
Okay.
Oh, I thought we were supposed to write not similar.
Oh, you can do that. I just kept it in the same line there.
Yeah.
Okay, take out figure 4. I think this is the big guy, the one that like filled up the page.
It's 812 is his original.
Okay, so I've already kind of answered the first question. We're so into analyzing them now. We're like, this is the big dude. He is much bigger.
Oh, I know these.
Ah, see, isn't this great? If I were to just have said, let's analyze this and see if you can find it, there's so much to analyze, it's hard to organize our brains around it. That's why these questions for the Top Hat Organizer, already by figure 4, you're already knowing what's going on here. Andrew, question or comment? Comment. Comment away.
I was just gonna say how many.
Oh! Along the side lengths?
Yeah.
How many can fit along the side lengths?
3.
3. On both the width and the height?
No, just the height.
Well, what about the width? Can I get 3 across? While he's counting, I'm going to go ahead and put that first point on there. I already heard somebody say, hey, 1812 is the first point.
Yeah.
Ah.
I can.
Andrew just looked at his pictures and he said it's 3 units big, or 3 little guys can fit along the height, 3 little guys can fit along the width. How does the point justify that same thing?
3 times is 10. 6 times 3 is 18. 4 times 3 is 12.
They are proportional. Holy cow, we've got a lot going on here. They are proportional. And so that makes them similar. What else does it make it? If they're proportional and similar, this is a true dilation. What would be like the
3x
rule
and
or
3y.
the direction to
3x, 3y.
3x, 3y. Now I have a question for you. I think you're going to be able to answer this already. If I'm going to have a dilation that's going to be similar, what has to be true with my directions?
They both have to be the same. The x and the y must be the same.
The x and the y have to be the same, or the number in front of it.
Yeah.
Do you know what this number is called? It is called, I'm going to write this very tiny. It is called the coefficient. The number in front of the variable is always the coefficient. So if we know it's a dilation, those coefficients have to be the exact same. And then it's just going to be a bigger version of what we started with. Yes?
So the very first one we did would be a coefficient.
Oh, yeah, and even this 3 here, this is a coefficient, but is it the same as the y's coefficient? No, it's not the same, so therefore it's not a dilation, and I changed the shape so it's not proportional and it's not similar. Let's look at figure 5. I think we're going to be able to fly through figure 5 because if I remember right,
It's just taller.
he's just taller. We stretched him out taller. Is his width the same?
Yes.
Okay, so that one stayed the same. So same width. Let's see. How many times taller is he?
He is
No, yeah, taller.
3
Now, how did you get that?
because it.
Are you looking at the point or are you looking at the pictures?
The point.
Ah,
612.
he's already looking at the numbers. Did you even look at the picture to see?
No.
You didn't even use it to check.
No.
He's like, these numbers tell us the truth, people. Now wait, tall. If I'm looking at tall, am I looking at the X or the Y?
The Y.
I'm looking at the Y. Okay, so 4 and 12,
That's times 3.
that's times 3. Now it's stayed the same width. Is that true?
Yeah.
Yes, it is.
So it'd be
What is it?
X.
X
And then 3Y.
and 3Y. So are we talking about a dilation here?
No.
Oh, darn. No, we're not. Are we talking similar figures? No. And they are not proportional. Now, I have a real life example I have to share with you. I mean, this is exactly what happened this year. We made ABAR posters, right? Teacher took the picture. She maybe added some words.
Hey, I remember this.
Okay? We had to send them to be printed. So basically, we took the picture, which is picture size. We enlarged it on the computer so it was on either a Google Doc or Pages or something. Hey, how do you enlarge pictures on a computer so that they stay proportional? Does anyone know how you enlarge them?
Yeah, you just grab on the corners.
On the corner. So if I have a picture and I want to make it bigger, I grab on the corner and I pull it out and everything else grows, the X and the Y, right? What happens if I just take in the middle of the top and I pull it
The
up?
height goes up.
Y.
All
It just affects the Y, just like my little smiley face guy. We just took the top middle point and pulled up and he just got taller. Nothing else happened. Well, this is exactly what happened with our posters. Do you see it? Which one was affected, the X or the Y?
The Y. The Y.
The Y. What gives it away?
Because people look way too tall.
Okay? They look stretched out. Look at that volleyball in the middle. Is that a volleyball?
No.
It is like an oval or something. Now, this is probably not as bad as our smiley face guy. If I were to give this a direction, I would probably say, I don't know, maybe like a 2X and a 2.5Y. I mean, it wasn't hugely bad, but is that going to be proportional?
No.
No. It's enough so that we can see it and we're like, that's not a good product. Yes.
Okay, when we write all these down here, the letter goes after, but why not if the letter
She's already looking ahead. Yeah, is there something different between these two?
Well, those are written fractions and the letters behind what those are. The letters are.
Well, and what kind of mathematical operation am I doing with a half X, comma, half Y? What am I doing here?
Making it bigger. by
Making it-
half,
you're
or-
Shrinking it by half.
Look at this. Remember when you first saw this, when you walked in, you're like, there's no way I'm going to know what this is about. Now you're already going, what did I do to my picture?
Wait, how do you know it's shrinking it?
How do I know it's
Because
shrinking?
Because it's
The
not
fraction
one
bar
letter,
is the
it's
divide.
another.
So I want this half as big. I want this at 0.5. So it's like if Matthew worked for a printing company and I give him a picture and I'm like, hey, I want this at half the size. This would be the direction he would
that'd
send
be
back to
easier,
the printing
yeah.
company.
I don't think of it, yeah.
He'd be like, make the X half as big, make the Y half as big. I think this is what they did for our posters. They gave this direction and we ended up with some weird stuff going on. Yeah.
Okay, so all of these we've done are multiplication.
Uh-huh.
But our last one, it's addition. So is that why the letter went first?
Did you notice that these were multiplying? Here I have X minus 11 and Y plus 3. I'm adding and subtracting, so that changed something, didn't it?
Yeah.
Okay. Look at figure 1 and figure 6. Figure 1 and figure 6 are going to help us answer this
It
question.
just translates.
Yep.
Oh, it just what?
Translate.
Did the size change at all?
No.
No.
Size didn't change.
It just
It's
translated
just
right.
yeah. Two.
Okay. And you've got figure 1 and figure 6 so you can see what's going on there. So you're saying it's a translation.
Yep.
Hey, when you look at the pictures, can you figure out which way it translated? Kind of like what we did with Miss Pac-Man. Am I moving left or right, and am I moving up or down? If I go from figure 1 to figure 6, can you figure out where is it translating to? So I go, am I moving to the
Write it
right?
up.
What? I'm moving right
And then up.
and right and up. So basically it's the same size, which is true of a translation. A translation won't change the size. The only thing that changes the size is the dilation. Aaron just looked at it and he said it moved right and it moved up.
Yeah. Each one went up or went 2 squares.
Yep.
Oh, moved right 2 squares and moved, I'm sorry, up? Is that what you said?
Up.
Up 2 squares. Okay. So it moved right 2 squares and it moved up 2 squares. Who has the list of points? What is the first point?
Or figure 6.
Yeah.
86.
86.
Okay. So you physically saw what happened to the shape. Now let's analyze the numbers. You said it moved up 2 and, I'm sorry, let me start again. Moved right 2 and up 2. If we compare it to the first,
Plus 2.
Yeah. So
Both of them.
you would do x plus 2 y plus 2.
it's really not that hard. The x value increased by 2, which means, remember when we worked with that transmographer and we said, if we wanted to move it right, you're like, what kind of numbers do I have to use? And you're like, oh, I got to use a positive number. And it affects the x-axis. So it moved it 2. And what happened here to the y? It went up 2. So if I'm adding or subtracting, it's moving it around, isn't it? Either up or down and left and right. What happened to the shape, though? The shape
Stay the same.
stayed the same. What's the mathy word for staying the same?
Similar. No, staying the same. Congruent.
Congruent. There we go. Okay, so now let's test it out. I'm going to give, you're going back to work at the print shop, okay? And I ordered a letterhead.
What's a letterhead?
Oh, you know, like Reno Valley, it says Reno Valley, it has a little picture in the corner,
Oh, okay.
you know, and kind of gives us the phone number and all of that. Okay, so I order a letterhead, and when I get it back, you people put the picture right here. I don't want the picture there. I want the picture up in the top left corner.
You gotta translate.
So, I'm going to tell you, this is what I want you to do. I want this picture, I want it moved over this direction, let's say 8 units, and I want it moved up 2 units.
So then
Could you write down the direction? Just write it down on the bottom of your paper there. Talk with your team, if you need to. What would be the directions that you would send to the print shop to say, hey, you messed up on her order, you put the picture right here. She wants it 8 units over this way, 8 units left, and 2 units up. That's where she wants the picture. Go ahead and write the directions. Yeah, just put it down there.
Similarities up below that.
Yeah, just put it down there.
No, if you're moving left or right.
So you're working at the print shop. I come in there, I'm all upset. I can't handle this. This doesn't look good. I don't want to send this out to my customers. Can you please move that picture? And you're like, sure, no problem. And you're going to write down the order, and it's going to look like, give it a stab here. Give it a stab. What's it going to look like? I want it moved over to the left 8 units and up 2.
Put X or X in right, and then Y plus 2.
Should I hire him at the print shop? Does he know what he's talking about?
No.
He does.
Is
He's-
it supposed to be another person?
Oh, Alyssa had this. Is that the same thing?
Yeah.
I don't know.
If I add a negative or if I subtract, do I get the same thing?
Yeah.
Mhm.
Yeah.
It doesn't matter. It doesn't matter. So X minus 8, move it over left 8 units, move it up to the printing department. We get that, and they'd be like, oh, okay, we know exactly what we want to do. Okay, I've got another question for you. Let's say, I'm like, oh, wait a minute. You know, that's a great idea, but it's a little small. Could you make it, I need it moved, but I need it twice as big. It's too small. Could you make up a new order form for me? It's still sitting here in the middle.
Twice as
So, but I need it moved. So I need this done, but gosh, you know, the more I think about it, I really need it twice as big. That's way too small. How would I do that? I want it twice as big. I want to dilate it.
Would you put the letters behind the numbers, or would it still be?
Or would it be 2X?
Where does the coefficient go?
Boom. I'm done, man. I got this.
Oh, you guys are like amazing.
I'm the best at this.
I think I need to hire you so that you can work at this print shop. You guys, and that's what your homework is? You're just going to get orders for a print shop? So I still have the problem. It's still stuck in the middle here. You already wrote this order out, and then I'm like, wait a minute. I need it moved, but God, could you make it twice as big? And you're like, sure, no problem. Let me adjust the order. How would you adjust this order? I want it twice as big.
2X, comma, 2Y.
But I still need it moved. So
we
it's
put 2x
minus 8, and then comma, 2y plus 2.
Wait, if you're doubling with the moving word?
It maybe would, yeah, you'd probably be like, well, now you're going to have it twice as big and it's going to be off the
So
page.
it'd be 4.
So maybe we should
4 and 1.
adjust it to 4 and 1. And maybe at the print shop you would have a computer that you could like quickly put this in and say, hey, is this what you want it to look like? And I could pre-approve of that.
Wait, why didn't you put it?
Because if I still move it over 8 and 2 and I blow it up,
It's gonna be
it may be off the
But it's
page
gonna
now.
go.
Yeah. So now maybe not slide it quite so much. Okay.
This still doesn't make sense. How do you get 2?
Oh, because I wanted it twice as big.
Oh, so you changed the 8 to a 4, so that when you
Oh,
made it
wait.
bigger, it didn't.
Right.
Drop the page up.
And actually, it's actually going to be 4 times bigger
What?
because
Making it smaller. If you're
Yeah.
changing the way it goes.
yeah, because there would be 4 of them in there.
Yeah, so by making it a 4, it wouldn't.
It should keep it on the page, I would think.
No, but if you change that to a 4, would it change your 2s to a 4?
No, because I just wanted it twice as big. I'm trying to think. Have I gone over everything that you need to know? So, okay, let's basically just review here real quick. If it's going to make it bigger, what kind of math do you do to it? You multiply, and it can be by a whole number. If I multiply by a fraction, what ends up happening to it? It shrinks. Okay?
Wait, so that's how you do like making it smaller?
Is that what like you would drag the corner?
Right. So if I wanted it, let's say I wanted it a 5th x and a 5th y, I want it 1/5 the size.
That's gonna make it really small.
That's going to make it really small. Yeah. And maybe you made it way too big, and I'm like, no,
We
please.
have to do this with fractions.
Well, what does a fraction mean?
Half
A fraction means
fraction of the number.
It's going to be a fraction of the number. So what's going to happen to the size?
Is it smaller?
It's going to get smaller.
Yeah, I
Okay.
still don't even understand how you got the other.
Now, I'm just making this stuff up as I go. So let's just say that we have a point 1510. And we want to make it smaller. So what is 1/5 of 15?
3.
3. So that point would be 3. What is 1/5 of 10?
2.
2. So this 3, 2,
Oh, it's just like rounding. I mean, not rounding.
division. When you multiply by a unit fraction, it is just like dividing by your denominator. Yes. Because you're finding, if I have 10 pieces of bubble gum and I'm going to give you 1/5 of them, I'm going to have 5 different groupings. How much are in each group?
Or
Well,
no,
if there's 10,
2.
2. Yeah. Okay, flip your paper over.
Which one?
The top hat.
Oh, shoot.
No, this is what you're going to work at the printing company, okay? And these are the orders that are coming in. You have customers coming in, and the first one says, I need this picture 4X and 4Y. And what you're going to respond to them is, what would happen? What would happen if a customer comes in and says this? You would say, are you sure you want this
4 times larger?
4 times larger? What would happen? It will be 4 times larger. So basically, you're kind of self-assessing your skills as the print shop worker going, do I know what the customer's asking? And you would say, are you sure you want this 4 times larger? And they would be yes. And would that produce something that is similar to what they give you?
Yeah.
Yes, that would produce something that is similar. And just for our information, what kind of transformation type is this? It is a dilation. Okay? There is a mix-up in here. And it is down here where it says 3x. It should say 3x, 3y. Yep, I typed that wrong. Now, you'll notice that there are some things that are a combination. Okay? We're going to be dilating things, and we're also going to be moving them, just like what we did on our example there. So, look at each order. Make sure you can word what would happen so that you can just tell the customer back, hey, this is what's going to happen if this is what you order. And then, is it similar, and what kind of transformation is it? You do not need to do the 3 questions at the bottom. Just fill out the chart for Monday.